Oh no, it's a bad day for the Krusty Krab. Plankton has taken over. Researchers on a boat are investigating plankton cells in a sea. The depth H of meters and at a depth of H meters, the density of plankton is modeled by this equation. Now look at that equation. That equation screams use a calculator on this one or technology. So between 0 and 30, they give us the density of the plankton. And anything above 30 meters, they're giving us this unknown function f, which we'll talk about later on. So for part A, it says find p prime of 25. Again, they don't want you to take a derivative. That's nasty. That's quotient rule, chain rule. It's chain rule, product rule. It's nasty. Just use a calculator or use whatever tool you use on the internet. Either one's fine. So p prime of 25, that's just going to be typing that in. And that's going to give us negative 1.179. And they're going to give you a point for that. But then they say something. Interpret the meaning in the context of the problem. So that's saying, well, what does that negative 1.179 mean for us? Well, what's happening? Well, this is the rate of change of plankton. So they're telling us that the plankton is changing. And in this case, it's decreasing. This is the change in density of the plankton. And what it's telling us, it says that, well, the density of plankton, we're going to write this as a sentence, is decreasing at a rate of 1.179. Now it's going to be, get the units, millions of cells per cubic meter. Millions of cells per cubic meter. And that's your answer. Plus 1 for it. There. So notice, decreasing rate. Tell me what it's decreasing by. Do not ever say decreasing and put a negative with this. No negative. It's got to be positive right there. Okay? That's just crazy. And don't ever put increasing and a negative. That's weird. Don't be that guy or girl. Whatever. All right. So part B says, consider a vertical column of water in the sea with a horizontal cross section. Cross sections with a constant area of 3 square meters. To the nearest million, how many plankton cells are in the column of water between 0 and 30 meters? Well, this question is, well, we want to know how do we get the population? Well, we know how to get population. I mean, this comes from just your science courses. We're going to take the density times the volume. Now, the volume is going to be a little bit tricky because notice they don't give us a volume. They give us an area. But remember, if I think of it like a tiny, tiny little circle of plankton, right? This has an area, but this also has a width. Well, how wide is it? Well, that's just the change in h. So if I take this area, multiply it by that width, that's going to give us our volume. And that's where we get our cross sections from. So we're going to take the density, which is this rho of h, which they tell us, times the area times that change in height to give us the volume. So this right here is actually our volume right there. And let's see here, we're going to rho of h. The area they tell us is 3 dh, we just leave it. Now this is going to give me a tiny, tiny, only one of them. But remember, we have infinitely many of them, infinitely many of these little areas right there. And we're going to add them all together. And what's the quickest way to add things together? That's right, to just integrate this from 0 to 30. And then you're just going to type that in your calculator, and you're going to get 1,675.415. Now, be careful. We're going to write this answer a little bit differently here because, you know, we're talking about plankton. Plankton are living things. We should never, ever leave a decimal for anything really living because it does also say that the nearest million. So we're going to say there are 1,675 million plankton. Oops, can't spell plankton. There we go. Plankton in the column of water. Look, you can use chemistry. H2O. All right. And the integral was worth 1, and your final answer, rounded, is worth 1 as well. Now notice in question 8 and question 2, they gave us a rounding thing. Read directions very carefully. Oh, I guess we should say for the height, from H goes from 0 to 30 meters. I guess we should say what the height changes to, okay? Yeah, there we go. All right, so let's take a look at question C. Question C is kind of an interesting one right there. All right, it says there is a function u such that f is between 0 and u. Now remember, f, what does f represent? F represents what? And the density after 30. So we're saying that the density, this is the density after 30. That's what this is telling us for all h greater than 30. And that the density model between 30 and 0 is 105. Now, what is that telling us? That there are what? What's that? 105 million plankton between 30 meters and an infinite. And, well, that's a pretty deep column of water. The column of water in part B is k meters deep, where k is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions for the entire column. Okay, so what is that telling us? So remember, from part B, right? So that, remember, our area for part B was 3. So what they're saying is if we're starting at 30 meters, how do we get the population? Remember, that's going to be the density. But the density after 30 is given by F. So it's going to be F of H times 3 dH. Remember, this is our volume, right? And that's going to go from 30 to K. Right there. This represents the number of plankton for H greater than 30. For H goes from 30 to K. Okay, now what did they say? Now that's worth 1 point right there. Now they say, explain why the number of plankton cells in the column is less than or equal to 2,000 million plankton. In other words, they're saying now use this to show why will the number of plankton never be more than 2,000 million. Well, in order to answer this, we need to find out, well, how many plankton are we totally ever going to have? And that's pretty easy. Well, we would need the number of plankton from 0 to 30, which remember we said was this P of H dH. Now, I forgot to multiply by the 3, so I'll put the 3 on the outside, plus all the remaining plankton, which is from 30 to K, or from 30 to infinity. So now what are they saying? Well, that is U of H dH. Now don't forget we got to multiply that by 3 as well. Now we can do this, and this is because f of h is between 0 and u of h. Go Cougs. So because f of h is between 0 and u of h, we can say that this is the most we can add on. We can add in terms of plankton. So this number we already got from part B, which we said was 1,675.415. Plus this becomes 3. We know U of H is 105 from above. And if you add those together, what you wind up with is 1,990.415, which is less than or equal to 2,000. So in other words, this is the most, well, I guess I should say units, million. This is the most we can have in the column. Right there. So this is a really tough question right here. So what you're going to get, you get 1 point for this one, 1 point for your integral and your answer, and then you get 1 point for just basically explaining why it is. Basically, that's the most that we can add right there. This is a tough question right there. We can go over this again later on if we need to in class, okay? All right, let's take a look at question D. Question D says a boat is moving on the surface of the sea. At time t is greater than 0, the boat has this following position. Oh no, look at this. It looks to me like they've given us a what? That's right, it looks like a vector. Where t is, now this I can see like in 2020, where we're just throwing a vector into this problem. We want to find the total distance traveled of the boat. Now this has nothing to do with the plankton, it's just a total distance problem. And we have an interval for that one. Remember, that just goes from 0 or from A to B. Our interval is the square root of x prime of t squared plus y prime of t squared dt. And for us, that's going to go from 0 to 1. X prime of t, you do not have to write out the equation, plus y prime of t squared dt. You don't have to write out the whole equations if you don't want to. You can just leave it like this and just type that in your calculator. This is a calculus question, and you get 757.456. So we would say that the total distance traveled, use your units, is 757.456 meters. Oops, that's weird way to spell meters. Meters. 1 point for your integral, 1 point for your answer. All right, so that's question number 2. This is a really good one. Try number C again, letter C again. It's a really tough one right there, but it's a good one to know for the AP exam. All right, enjoy.